I don't know if you've ever heard this before, but algebra is considered the universal language of math. And anything that you can represent using words, you can actually represent using symbols. And that's what algebra is. It's about just representing things, words, ideas, phrases using symbols. So today we're going to look at what that means. And for the purpose of this lesson, I'm going to think of two numbers and I'm going to call them x and y, right? So let's say I have two numbers. Now, x could be any number, y could be any number. But for the purpose of this lesson, I'm just going to use x and y to represent two numbers. And if I want to talk about the sum of x and y, well, you might remember that sum, or you may know that the sum of anything means add, right? So if I talk about the sum of x and y, I am referring to x plus y. And if I'm thinking about the difference of these two numbers, x and y, well, you may know that the difference of any two numbers, in this case, we're calling them x and y, is the subtraction of the two numbers, right? So if I look at the difference of x and y, then I can write that as x take away y, or x subtract y. Similarly, you may have heard of the product. The product refers to multiplication, the answer that you get when you multiply two numbers. So the product of x and y in algebra, we write this as, well, it means x times y, and that gives us xy. And then finally, the fourth operation is the quotient. Can you guess what the quotient is? Well, the quotient of x and y is the answer that you get when you divide x by y. So the quotient of x and y would be x divided by y, but in algebra, we write this as x over y, like a fraction. So let's look at this exercise where we have to translate each of the following word phrases into algebraic expressions. So the first one is 5 times a number x. So times, as we know, means to multiply. So 5 times a number x would be 5 times x, literally 5 multiplied by x, which in algebra we represent as 5x, right? So for example, if I had 2 times a number x, well, that would be 2 multiplied by x, which would be 2x. The second one, 3 times a number x plus a second number y. Well, you have to do it piece by piece, right? Again, times mean to multiply. So if we say 3 times a number x, we just learned that if you're multiplying by x, like you had 5 times x here, that would be 5x. Therefore, 3 times a number x would be 3x, 3 multiplied by x, plus, and plus means to add, so 3x plus a second number y. The third one, 7 times a number x minus a second number y. Well, 7 times a number x would be 7x, and minus a second number y. Well, minus means to take away the second number y, right? And number 4, half times the product of x and y. So let's just recall that product means to multiply. Times also mean to multiply. So half, which is 1 over 2, times, multiply, the product of x and y. Well, the product of x and y would be x times y. So this would give us 1/2 xy. And we can also write this as xy over 2. Finally, number 5, 2 times the product of two numbers x and y divided by a third number x. Well, the product of the two numbers x and y is xy. We learned that up here. 2 times that would be 2 times 2 multiplied by xy, which will give me 2xy. And then it says divided by a third number, z. So that's this, right? However, in algebra, for division, we write it as a fraction. So 2xy divided by z would be written as 2xy over z. And there you have it. It's really important to understand what these expressions mean, what they translate to in terms of words, because when you have to solve algebraic expressions or even like substituting a value into a formula, which we will do soon, you have to understand what exactly is happening, what operation you're doing.